Hello? Okay. Looks like everything is working. Okay, here goes nothing. Hi. Today, I'm going to be studying stream. I've been thinking a lot recently. That's something I usually do. I was wondering, like, well, no, I wasn't actually thinking at all, but like, who does this benefit? Because to be honest, I don't even watch these calculus streams, and like, if somebody stumbled across these and they watched it, like why would they watch this when they could just watch a Khan Academy video? So like I was wondering why I even make these, but actually I remembered. It's because if I didn't make these, I would never do the homework. And on my recent calculus test, I got obliterated. I got killed. I got like my bones broken. So in 1 month or less than a month now, I'm going to have a calculus test. And I have to try my best to be successful so I can have a better life. Just remembered. Okay, forget about all that. Today's picture is number 1 is Yotsuba from Yotsuba. This is supposed to be when I think she drinks a glass of milk and then she says something like recommendable. But on the first thing, like the smaller line I drew it as her mouth, and then I thought it was too small, so I drew a bigger one. And now she just looks like an angry person. She looks like I think the guy's like Angry Freak from like back in the day when there were Flash games. And then the second picture is Yoshinoya from Hidamari Sketch. I can click on it. So this picture, I thought it turned out pretty good. I It's okay, but this is like the way the artist does like a little chibi sketch. Like the way she draws it in like a less detailed way, and I couldn't even like mimic her when she was doing that. So I guess, drawing is pretty hard. That's why I do it every day. That's why I do it every time I stream, so I can improve. But yeah, basically, all right. And she's like twirling around, but the difficult part was like making her head face backwards. I think I drew her neck. Like the mangaka did not draw her neck, so I guess it was like easy for her to look back. This like, well, it does look like she's looking back. And then the thing poking out of her arm is supposed to be like her boob. She has like big boobs. But I messed it up. So whatever. I'm gonna go here and and we're gonna study, yes. And okay. I'm gonna study 9.1, which is vector functions. Okay, basically can't show I'm allowed, but I found there's another textbook which I think I am allowed to show you, and it's like the free textbook on OpenStax. That's not what I would be studying, so I don't know if I can even. Okay. Okay, so basically they're saying that a curve is a set of ordered pairs. So C on a parametric curve has the terms like y and x. On the x and y coordinate, of a point on the curve are defined by a pair of functions x equals f of t, y equals g of t, that are continuous on some interval as a is less than or equal to t is less than or equal to b. This is just like any number, as long as it's 1 or 2. As long as t is like less than or greater than that. Something like set of ordered triples where x equals f of t, y equals g of t, z equals h of t. Okay. They're continuous on interval defined by whatever vector valued functions. So basically what they're saying is that it's like a curve is made up of 3 different functions or 2 different functions depending on if it's 2D or 3D. Okay. It's often convenient in science and engineering to introduce a vector r whose components are functions of a parameter t. Okay, say so. Rt equals, and then they do this thing where it's like a triangle bracket. F of t, g of t equals f of t I plus g of t j, where I and j are like the different planes. Vector valued functions here. Okay, problem with me if you're studying is I don't really focus. Like I kind of like skim over the words, so maybe I should just read all of them. As shown in figure 9.11, which is curves defined by vector functions for a given value of the, say, t0, the vector rt, oh that's not t0, that's t initial, is the position vector of a point P on any curve. In other words, as the parameter t varies, we can envision the curve C being traced out by the moving arrowhead of RT. So they're saying something like this here. I'll draw it for you. Here's C, then it goes like this. Oh yeah, the teacher taught me this in school. Okay, I didn't really. xt0, y here. Even C, rt0 equals x0 yt. Okay. That's not all. Now they do it in a 3-dimensional space. X, Y, and in the Z plane. It goes like this or something. No, I don't know what. Saw parametric circular helix, where they say graph the curve traced by the vector function. R of t equals 2 cosine ti plus 2 sine dj and plus t of k, where t is less than or equal to 0. That's like this. So how about I actually work on the problem? Guess. Y x. Now if you have 2 cosine of I is also for x, this is for y, and this is for z plane, correspond to each other, kind of. So if you remember, a cosine graph goes like this. Okay, actually I don't remember, literally don't remember. Okay, I guess I'm gonna cosine graph. One starts at 1 and the other starts at 0 for a sine graph and a cosine graph. Okay. Cosine graph starts at looks like 1. So here's 1, 0, and negative. Goes like this. Goes like here down to a negative 1, 0. It's negative 1. This is like pi. It's at 0 when at like 90 degrees is pi over 2. Close enough. And it's at 1 and it's 0 degrees or 360 degrees. And then negative, and then sine starts from half for some reason. Then it goes up, down, up, down. So it is kind of like the opposite. Oh, it doesn't start at 0.5. It starts at like 0 or something. I'm not qualified to teach mathematics, so I don't know what I'm doing. What if it went up like this? 2 sine. It goes like this. And tk is 0. So if you put all that together, as it goes this way, it's gonna like go up like this. Something. This. And it's supposed to be like a circular helix. Okay, no, I did it all wrong. Parametric curve of the equation are x equals 2 cos t, y equals 2 sine t, t equals t. By eliminating the parameter t from the first two equations, get x squared plus y squared equals 2 cosine t squared plus 2 sine t squared equals 2 squared. Okay, well. How could you even eliminate the parameter t from these two equations? Copy. Okay. Videos and stream. Go to jail. Okay. So it's probably good. Probably not a good idea. Listen to me. I guess. Why were they allowed to eliminate parameter t from these two equations? See that a point the curve lies on the circular cylinder. T winds up in a spiral or circular hex. Basically, they're trying to The curve in example 1 is a special case of the vector function. Example 2, filling up, graph the curve. How do they know? How do they know that a point on the curve lies on the cylinder x y squared? Things are designed for t is third component. Property of limit: if lim of t approaches r1 at t is L1 and a t is L. Okay, so what they're saying is if t approaches the smaller number, then r1t will see L1. T is a scalar. What a scalar is means that it doesn't. Okay, gotta look up the difference scalar versus vector. I wonder if this will come in handy. Okay, they're basically just saying if you multiply the limits together, then you know you can add limits and then you can subtract limits and you can multiply them or something. Derivative of a vector function. Find f of rt equals ft, gt, and ht, where they're all differentiable. Limit of each component yields the desired result. And a smooth curve. Okay. Seems parallel. The limiting position of the vector rt is the tangent line at Parametric equation x squared y equals. Ow. RT equals I K is 7K. What they're telling me. Now take the derivative. Our derivative of t. Derivative of t squared is ti plus 2t minus 1j, then minus 7tk, 7k. Okay. So r prime at r prime at 3 equals 2 times 3 is 6 plus 2 times 6 minus 5 I j minus 7k, which is tangent to c at the point position vector is r3, which is the normal one, equals 9i 6j, because it's 3, yeah, and then minus 7 times 3 is 20k. Okay. That is here P9 6 1 in component r prime 3. We see that the parametric equation, the tangent line r, x equals 9 plus 6t, y equals 6 plus 5t, z equals negative 21 minus 7t. So the question is why. It looks like that they combine the 9i and the 6it, because here's like the normal component and here's the component that's affected by t. Something like that. What was the question? It said find parametric equations of the tangent line to the graph of the curve. So basically they're asking like what's tangent to this, and if you take the derivative, it's like tangent. Yes, you know, the reality is actually I have no idea what I'm doing. But even so, even still, I have to make an effort. Okay. Derivative of a vector function. So let's say r at t is equal to, if I put on this light, is this better? Yeah, that might be better. If I turn, that doesn't really look that good. That is a sec. 1 second. Okay. Okay. Let's get back to it. Oh, it wasn't t squared, it's actually t cubed minus 2t squared I plus 4tj plus e negative tk. Oh, they already derived it. They're just saying that you can derive it 2 times. So r prime of t equals derivative of t cubed is 3t squared. The derivative of 2t squared is negative 4t I and plus 4t derivative of 4t is 4, well, with respect to t, and then the derivative of e negative t is negative e negative tk. And then they're saying that you can derive it again. So our double derivative of t equals 2 times 3 is 6t minus 4 I. The derivative of 4 is nothing. So it's plus 0j. The derivative of a constant is 0, and then to derive this, you take the negative t and you bring it down, so now it's plus e negative t. Then they're talking about the chain rule theorem 1.3. If r is a differential vector function and su of t is a differentiable scalar function, then the derivative of rs with respect to t is dr over dt equals dr over ds over dt equals r prime s u prime t. So yeah, basically I don't know what this means. Cut them out like this because they're equal. Okay, if rs equals cosine 2si plus sine s sine 2sj plus e negative 3sk, where s equals tf4. Think for a second. Wow. I'm done. Chapters 3, 7. I have to do 1 chapter a day. I don't have. Basically, I have 30. Okay. You guys think I can win? You guys think I can survive somehow? So what they're saying is that I don't know what they're saying. Looks like you can have to. Okay, can you wait? Okay. It looks like you're allowed to use the chain rule or something. Oh. Okay, so what they're trying to tell you is here derivative of cos 2si is and when you do derivatives with respect to r, you ignore t and you leave as a constant. So you just take it out. It's negative 2 sine 2si minus, so a plus 2 cos 2sj. Cos is inside here. Then the derivative of 3s is you take it down and it's minus 3e negative 3sk. And then it looks like you multiply everything. Because you remember here they were talking about, I guess I didn't write it very well, but this is r prime and this is prime. So the derivative of s, which is equal to t4, you derive it's equal to 3t 4t cubed. So you multiply everything by 4t cubed, multiply 2si, or multiply I, j, and k. Okay. Negative 2 times 4t cubed is negative 8t cubed sine 2s, and then it looks like you can substitute in t4, the original one, because I don't know. I plus 2 times 4t cubed is 8t cubed cosine 2 times t4 is 2t4 minus 3e minus 3 times 4 is negative 12t cubed, negative 12t cubed, e minus 3 times t4. Okay. The k, and this is j. That's I. Okay. Now 3. Rules of differentiation. Let R1 and R2 be differential vector functions and U to be a differential scalar function. R1t plus R2t. Take the derivative of respect to t. Goes R1 prime t, R2 prime t. Okay. ut times R1t equals u of t R1 prime of t plus u prime of t R1 of t. Okay, so that's basically the, what is it, the chain rule. Like when you multiply stuff. When you're multiplying two functions, f of x, g of x, you're deriving it. D over dx, f prime times d prime dx x plus f x d prime x. That's how it works. That's how it works. That's what they were telling me the other day. Then R1t x R2t, like a dot product. Okay, R1 1 prime t. Yeah. Note of caution. the cross product of two vectors is not commutative. Order in which R1 and R2 appear, Part 4, Theorem 4 must be observed. Okay, so what they're saying is, I put the prime here, that's wrong. The prime is here, and then the prime is here. And it's a specific, not R1 first, and then R2. Looks like you have to do R2. Integrals of vector function, if they're integrable, okay, that's a pretty good review. Didn't know that. Didn't know that. FG and H are integrable. So like derivative of here RT equals derivative of FTI plus the derivative of J. It's the derivative of the whole. And the same thing if you have AB, also AB, AB. Okay. The indefinite integral of R is another vector R plus C such that R prime equals. Okay, I don't know what that means. Integral of a vector function. If RT equals 6t squared I plus 4e minus 2dj plus 8 cosine 4tk. That means that when you take the derivative, okay, try it. Take the derivative with respect to t, this would be 1 over 3, so 6 over 3 t cubed I, you know, this is 2. 6 divided by 3 is 2 plus 4 negative 2t. This would be multiplied by negative 2, but this would not change. So it would be negative 8e negative 2t, then plus 8 cosine 4t. Be like this. This would be minus 2 sine 4t k, because when you derive it you would multiply it out by 4 and it would turn into a cosine negative. Okay, let's go, let's take a look. If I was right, 2t cubed minus minus 2e minus 2t, so it looks like I was wrong on that one. Because when you derive it, you're supposed to multiply, so when you integrate it, you're supposed to divide it. So this is 2, my bad. And then this one is plus 2 sine 4. I guess I did that wrong too. It's just supposed to be a plus. And you're supposed to add the C1 plus C2 plus C3. Supposed to add the constants because they're not getting removed. Okay. And the length of a space curve. Okay. If it's a smooth function, it can be given by showing the length of the smooth curve traced by R given by S equals BA F prime of T squared plus G all root is equal to BA. The integral of is the norm. If two lines like that, it's a norm. The arc of a parameter. So they're saying that Consider the helix of example 1. The norm of r prime t equals root 5. They're saying since this r prime of t, the root 5, follows that the length of the curve from r0 to an arbitrary point r is. And they're saying that s equals t0 5 du equals root 5t. Okay. Where we have used u as a dummy integral of variations. Doesn't really matter. The SL5, we a vector equation of the helix as a function of arc length. Okay, I wonder what is arc length. I'm supposed to remember all this stuff, but I literally forgot all of it. We obtain a vector equation of the helix as a function of arc length. I'm gonna have to look it up. What is the function of arc length? A lot of Googling stuff. 13.3 LibreText, arc length and curvature. Okay, I think I know. Part that's depressing is when you don't even think that you understand. They're saying graph the curve traced by the given vector. So question 1. R of t equals 2 sine ti plus 4 cosine j plus tk, where t is less than or equal to 0. How to graph graph the curve traced by the vector function. Also, I finished all my homework, by the way. This is the first time in like a week where I don't have a deadline due at 12 p.m. at 11:59 p.m. It's like I feel really happy, but next week I'm gonna have a bunch of freaking deadlines. It just never ends. Okay. Looks like someone's doing an example on YouTube. In the chat, just deleted it. Okay, I'm gonna have to be quiet for a little bit because I have to figure this out. Okay, copy it. Parametric. Oh my god, they're pulling out the trigonometric identity over. No way. Okay, so here's what they're saying. 2 sine t squared plus 4 cos t squared equals 1. You know why? Because x squared plus y squared equals 1. I think that's what they might be. Here's this. And oh, this might. Okay, well, she factored that out, but it doesn't look like I can do that because if I factor it out, it's gonna be 4 sine squared t or cos. Okay, let's go back. Get my. I got no idea. Also, my camera is in the way. What about this? Kind of. I want. Vector function. A pure number. Graph the projection. I have no idea how to do this. So basically, I read the chapter for nothing. Usually, I think like, oh, since I read it, I understand it. But you know what? I think I've grown a little smarter than before. So I can know for sure I'm just think. Okay. Not get so down on ourselves to what 11. Okay. The vector function. Sketch the curve C. Okay, they wanted me to do more drawing. Find the vector function. If I just look it up. C. Okay. Sketch curve C. Because it's like, why did I even read the thing if I don't understand what's going on? Wish there was an easy to learn stuff. 11. B equals squared. I brie. I. Math tutor. Tutor. It's cool. Well, basically I'm trying to find the vector function that describes the curve C of intersection between the given surfaces. Sketch the curve C used as the indicated parameter. How am I doing? Yeah. I guess I'm okay, but I'm trying to study for my calculus 3 final. I have it soon and I just did really bad on my second midterm. So I'm trying to, I don't know. Obviously I'm trying to get a little smarter. Trying to stream at the same time, but stuff is really hard. I'll tell you that much. Okay. I already wrote it, so why am I writing it? Maybe I could look up the answer. So yeah, this isn't me teaching, I'm not teaching a course or anything. I'm just trying to figure it out. So you're not gonna learn very much over here. Math tutor, I guess you know. Just make sure you can get help, right? Guess. School. At my school, they probably have somewhere I can get. Right now, I'm just gonna try to learn stuff by myself. Squared. Saying like x equals t. That's how you got t squared. You're saying y equals x, right? Then x, y, and z. That means yes. That's how you did it. Okay. Lets you get help from any. Your prof lets you get help from. Oh, like some places don't allow you to get help from other people. That's a little weird. I don't know about that. Never thought about that, but okay. That's what you mean by this. Like, how do I? Is there a way to like draw that? The x-axis. This is the y-axis. This is the z-axis. Okay. Would be going up by like this, out like this, right? Would be going like out here. Uh oh. I can just like, what do you call it? I don't have to sketch it, but I can do t equals 1. It's like 1, 1, 2, t equals 2. So like 4, 4, 4 times 2 is 8. Okay, I get it. Oh, so that's how you do. You have to pick like 1, 1, then 2, up like here. Kind of be like that, I think. Okay. Uh, just t squared. Not t. Hold on. Oh, so you think it's like uh what you think? Okay. X, because here they put x is equal to t, right? Oh yeah, here. T, y, then it's like that. Yep, right. You were right. How do you sketch it? Okay, I guess the sketching part isn't really that important. Okay, I guess it's time to move to the next. 14. Okay. Question 14. Z equals x squared plus y squared 1 and x equals sine t. What they're saying here, t is 1, so sine of t equals sine squared t plus y squared, and then over here 1 minus sine squared t equals y squared. Then you can square root it like this to get y. So, or were they trying to do it like, because if 1, isn't it sine squared t plus cos squared t equals 1? So like, if they had sine squared t minus 1, it would equal minus cos squared t. Maybe that's allowed, so hold on. Would it equal y? That means therefore y would equal cos squared. Or it would just equal cosine. Plug in values for sketch. In the case of the first problem, t equals -2, -1 and 0, 1 and 2. Then okay, start to sketch it. This is sine squared equals y squared. Feel like this sine. Okay. Yeah, that's probably okay. So now, in order to plug it in, that equals y, then x squared, so z, or 1 equals z, sine t equals okay. Now basically what they're saying is that x, y, z, so sine at 0, sine at 0 is 0, right? Okay, so y at 0 is 1, z is always going to be 1, and it doesn't really matter. So if you go like 1, go 1, sine at 1 is that how it works? Or is it gonna be like, wouldn't it be easier to do sine at pi? So at pi, sine is, I don't know, I should know. Sine is 1. So if you look at x, it's gonna be 1. Then this is gonna be here's pi. It's gonna be 1, it's gonna be 0. Then it's gonna be 180 plus like 90 sine. Sine at 270 would be -1. Be 1 minus -1. This would be 2. This would be sine t of x 160 sine. Okay, hold on. What did I just do? I did 180 sine. So 270 degrees is pi over 4. Say it's 270 degrees. 60 degrees. 360 sine t 0. Then here is 0 and it's 1 again. What if you do like 360? Okay. And this is I think it's root 2 over 2 squared. Again, root 0.5, like root 1/2. Okay, I kind of get the idea, but I really do not want to draw this. 0 pi twice. This is where it's 0. Okay. (405) sine. Oh. (0.70) kind of. Then here's okay, that's a half squared. If I were to draw this x, y, and here's z, you try pi over 2 as well. Yep, you're right. 90 sine. Guess I have to put it like, yeah, this is 1 pi over 2. 1 minus 1 is 0. This is 1. Okay. So 0, 1, 1. Oh goodness. 1 is up here. Here is 0. Here is 1, so it goes like over here. 1, x is 1, y is 0, and z is 1. It's exactly the same as the second point. And then x is -1. That's like goes down here. Y is 2. That is 1. It goes like over here. So it's like this, I guess. Plus 270 is not 2. There. Some of your sine t and cos t is incorrect. Not 2. We're talking about over here. I guess. Here, this is like my y and my z. Actually, so how did I get? So the way I got it, it was 1 minus what was it? Was it 270? So it's 1 minus is equal to 2. Okay. If I keep doing this, okay, basically it looks like I got the general idea. Probably. I'll do another problem. I'll try to make it neater this time. So what is your math tutor? There are a lot of people on Twitch doing math. Do you like, well, I guess obviously don't math tutor. Is it hard? Well, thanks for chatting and thanks for hey. Have a nice okay. Find r prime of t and r double prime of t for the given vector function. Okay. Oh. RT equals the natural logarithm of I plus j is plus t is greater than 0. Okay. Let's try derive. I don't know the derivative of the log. Okay. This is j, this is a 1j, so I gotta look up what's the derivative log of 1. Okay, remember this. Ln equals 1 over x. Later, up you just okay. Now, thank you. Okay. This goes away. There's no j, 0. And r double prime of t. So want to derive this again, it's gonna be this is the quotient rule. Prime times g, this is 0 because the 0. And 1 times 1 minus squared. So is that right? Negative 1 over dog just okay. Okay. All right, so that's basically the question. Find r t and r double prime t for the given function, and then I guess you're supposed to look at when it's greater than 0, like it's approaching infinity, I guess it would be like 1 over t. T would grow, t would become smaller as it reaches the limit. Oh, this is supposed to be t squared. And then here t would become like way smaller. So basically, that means is it's parametric equations or just differentiation of non-integer values. Guess it's both. I don't know. Basically, this question right now is just find the derivative for the given function. So I okay. But yeah, this topic is vector function, so I guess it encompasses both of them. And now I'm doing the homework problems, so they all have like different stuff in them. Okay, I guess that's okay. So they didn't tell me to sketch it. Are you also an engineering student? Studying engineering. It's calculus 3 for me. Did you already graduate? Or see described R graph R prime the decade. Oh, you're like in you're about to go to college while you're about to finish high school. I guess I'll tell you firsthand. Studying engineering really hard. Honestly, I don't know. I guess I don't regret it, but like holy crap, this is so hard. Study engineering. Work hard, I guess. So if you derive this, it's gonna be derivative of cosine is negative sine I. This is sine, so plus 6 cos t j. Heisenberg 29. Hi, doing? Famous Heisenberg. Say my name. Okay. Doing here. At the indicated value of t. Okay. So basically, what they're saying is what's r at pi over 6, which is like pi over 6 180 divided by 6 is 30 or something, right? Okay. Oh, here I can show you guys. So Sine of 30 is half. So what they're saying is no, it's all wrong. Cos at 30 is this root 3 over 2? 3 root over 2. Okay. So this is 2 root 3 over 2, which I guess it just goes away. So it's root 3. No. 3 I plus, and then this is half. Sine at 30 is half times 6 is 3. 3j. Okay. R prime pi over 6 equals half. So it's minus 1 I. And then here is plus 6 cosine t. So it's root 3 over 2 times 6. So it's going to be 3 times root 3j. Sine pi over 6 is half. No, that's right. Oh. Okay. Alright. Looks like that's the answer. Okay. That's right. Okay. Awesome. What about you, Heisenberg? Also studying engineering? Okay, so now they're telling me to evaluate the given integral. J sine pi k t. That's cool. Supposed to be calculus. I don't know. Maybe some people learn this in school. Evaluate the given integral. Okay, fine. Do you evaluate integral at the power of a half? 2t plus 1. 2t plus 1. The power of negative 1 over 2. Then you can integrate this. Okay. And I already forgot. Are you supposed to do u substitution? Or can you do integration by parts? Let me just try some stuff before I Google it. 2t plus 1 equal, supposed to be the other way around. You guys learned this? I didn't learn this until university, so I don't know about it. But like when you're integrating stuff, you're supposed to do you can replace it with u and then you can differentiate it. So 2u d equals 2. This is dx. And then you're supposed to isolate for dx. So dx equals du over 2. So now that I have this stuff, now I have u negative 1 over 2, and then it's du over 2, right? Or multiplied by 1 over 2, and then I factor out the 1 over 2. 1 over 2 out of here. So now I can differentiate for u. That basically means that Zone Ranger t dt equals that guy. Yeah, you were the one before who was helping me. Hi. Hi again. Doing t equals d. Oh, and it wasn't supposed to be dx. It's gonna be 2u minus 2u for negative 1 over 2, because when you, then it's gonna be, I almost got it. Hold on, just give me a second. Really close to figuring. You add 1 here. It's gonna be 3 over 2. No. Holy crap. It's gonna be 1 over 2 positive, and this is gonna be 2u. Holy crap. 1 over 2. Yeah, I should have had dx, you're right. Or I should have had dt, you're right. Okay. When you multiply it here, it's gonna be, okay, so this is a positive actually. Okay, so I finally got it. Hold on. Running out of room. 1 over 2, 2u to the power of a half. That's the integral. And then you multiply by half. Or are you supposed to multiply it after? Now it's u 1 over 2 to the power of 4 and 0, or integrated across 4 and 0. So now it's going to be 4 to the power of a half, which is minus 0 to the power of a half. So it's going to be 2. And also, is this even supposed to be a negative? Okay, well, I was trying to do it on my own, but I might have to plug it into a calculator. 4 to the power of a half. Oh. What about 4 power of 2? Okay, it looks like I did something wrong. Because this, okay, I messed it all up. Use substitution, you need to change the limits of integration. This is supposed to be a positive. Alright. I ruined everything. Okay. Start over again. Okay. Let me try one more time. Because I thought that it was an I, but it wasn't. Or I thought it was a negative, I thought it was negative to the power of negative half, but that's not true at all. ITKT. Okay. Try again. So here, this is 2t plus 1 to the power of a half, not to the power of negative a half. If it was negative of a half, it would be like 1 over that. Okay, so now it's okay now. So u equals 2t plus 1 dt. du equals 2 dt. Okay. And then du over 2 equals dt. Okay. That part's right. So now it's u 1 over 2 integral 4 0. I guess that part didn't really matter, but now it's going to be you add it over, so it's going to be 3 over 2, and this is going to be 2 over 3. So when you multiply it, it's going to turn back into 1 when you derive it. Okay, and times a half. Plus c. So now it's going to be 1 over 6. And you have to replace u back with like what it was before. So 1 over 6 times 2t plus 1 power of 3 over 2. U equals 2t plus 1, no dt. This? Okay. Well, maybe I'm wrong. Okay, anyway. Let me just finish the problem and then I'll look it up. Look it up on I'll look it up on integration calculator and see if I did it right. Okay, and now finally this is 4 and 0. 8 plus 1, 9, 1 over 6, power of 3 over 2. I don't know how to do this without power of 3 over 2. It's 27, so what was this? 27 divided by 6. Okay, here is 4.5. 4.5 minus 1. 1 to the power of 3 over 2. It's just gonna be 1. 1 minus 1 over 6. Yeah, it's not looking good. Not ut 2t plus 1 dt. But don't you have to change the... Is that what you're talking about? Don't you have to change the limit or something? Okay, so 4.5 minus 1 over 6. Okay, how about this? It's 26 over 6, which is 13 over 3. I, okay? Minus what this this is an even number question, so they don't even give you the answer. In the textbook, for some reason, they don't give you the answer for like even number ones, only for odd number. I don't really know why. Like, wouldn't they want students to have all of the answers, like to be able to figure it out? Or is 0? Negative t to the power of 1/2. Derivative. Okay, so I just did this, right? It's gonna be 3 over 2. Negative 2 over 3 t. 4 and 0. Okay. 4 to the power of 3 over 2. It's 8. 8 times negative 2. Negative 16 over 3. Okay, and this is 0. Like minus 0. 3 over 2, that's just 0. So it's minus 16 over 3j. Okay. Now for the last thing, it's sine I t. So that means sine of 90, which is 0, isn't it? Nope, it's 1. So if it's 1 times t, it means I don't have to take the integral of that, right? Or do I have to? Okay, let's try it. I don't want to. T40. This is just half t squared. Then you take 4, 16 half, it's 8, minus 0, plus 8k. Okay. Alright, looks like you guys are, I don't know. Basically, we're not, okay, here, I can look it up in the integral calculator. Oh, and I don't think I forgot the 1. I forgot the 1 in the thing. Oh my god. No. No, I didn't forget the 1. Okay. Well, basically, I don't know who's right. This right? Never be able to figure it out. 1 over 2 times 2 over 3 equals 1 over 3, not 1 over 6. Damn it. Yeah, you're right. Where? Okay. Guess. Should I redo this until I get it right? Guess that's what you have to do. Good student, right? Usually I just skip to the next one. It's fine. Let's go. But there's no way of figuring it out. 1 over 3. Okay. Relax and go step by step. Yeah, alright. Let's try again. Okay. 4, 0, 2t plus 1i. Okay, minus root t j plus sine pi k t. Two t plus 1 power of 1 over 2. Okay? Integral. Integrate. Okay. Let's see. U equals 2t plus 1. du equals 2. And Zone Ranger is saying that you're not supposed to add the dt? Because if you do this, isn't it dt here? And then you're supposed to solve it for dt in order to get du. So du, you divide it by 2 equals dt in order to replace the dt over here. Does everyone agree? You guys agree? Du equals 2 dt. Du over 2 equals dt. Okay. Alrighty. So now this is gonna be du and 1 over 2. We're gonna factor out the 1 over 2 here. 1 over 2 integral of 4, 0, u to the power of 1 over 2 du. Okay. And then integrate this. You're supposed to do add it and then divide it. So now u plus 1 is going to be u 3 over 2 power of 2 over 3. Okay. And it's no longer 0 to 4 on the du integral. You're right, I forgot about that. Damn. How do you fix it? I forgot. How do you change the bounds on the integral? Is it like you put it here? Is it gonna be like 4 over 2? Use u equals 2y plus 1. Okay, from here. So what? So now is y is equal here. Okay. U equals 2, 4 plus 1. U equals 9. And then u equals 2, 0 plus 1. Okay. Thanks, I almost forgot. 1. Okay. Now it's 9, 1. And now I'm supposed to replace it. Okay, and you have to replace it with 2t plus 1. 2 over 3, 2t plus 1 plus... Oh my goodness. I shouldn't be doing this in pen. I should be using a pencil. But the pencil is so, the pencil is like the writing is too light. That's why I stopped using pencils. Okay. 9, 1. Don't go back to t. Why? Why not? You? I changed the limit. Oh. Okay. Alright, I guess. 9. I look this stuff up. I don't even know this stuff. Damn. Trouble. Okay, this is 27 times 2 over 3. I don't even remember how I do this thing. How much I need. Times 2. 54 divided by 3. So here's 18 minus 1 to the power 3 over 2 plus minus 2 over 3, right? You can just substitute in u. That's a perfect changing limit. I dropped it half in front. Here. Nine, 1, 3 over 2, 2 over 3. What did I drop? Oh, I forgot the half, right? Is that what you're telling me? Yeah, okay. 2 over 6, which is 1 over 3, right? 1 over 3, u 3 over 2. And now I can do it. So now it's 27 over 3, right? Equals 9. And now 1, 3 over 2 times 1 over 3 minus 1 over 3, which is... What is this? Well, we just got it, right? 27 over 3 minus 1 over 3 is 26 over 3. Is it finally right? Does everyone agree? Yes, that is correct. Let's frickin' go. Clip it. This is a top 10 mathematic moments on Twitch. Okay, now we have 2 more stuff to do. Negative t. Okay. So now we have to, it's negative t to the power of 1 over 2, right? Take the derivative. Let's take this out. And this time, since it's an easy one, we don't have to change it, right? So now it's going to be 2t, going to be 3 over 2, 2 over 3t. Negative. Put the negative back in. And now it's going to go from 4 to 0, right? Negative 2 over 3t, 3 over 2. Then it's going to be 4 to the power of 3 over 2. 8 times 2 over 3. So negative 16 over 3. Then minus 0, which is just 0. So it's negative 16 over 3. J. You guys agree? Okay. It's really messy. It's even what they were asking. Evaluate the given integral. Yep. Yeah. I need a mind where I write things. Absolutely correct. Yes, I guess I never learned to be like organized in school. Okay. Let's try to be more mindful then. Sine pi k. It wasn't k, was it? It was t. tk. Yeah, so here I also forgot it. T. So here, am I allowed to evaluate the pi inside? Is that allowed? And that's not pi, that's 180. Which is 0. But if it's 0t, doesn't that mean it's 0? No, I'm not allowed? Alright, fine. It's sine pi of t. Oh, is that how it is? Okay. Pi times t. Okay. So, basically what you have to do is, if you're integrating with respect to dt, that means you only have to look at dt, right? So it's gonna be negative cosine pi of t, because t is a constant, right? Or t is 1 anyway, so it's not gonna change. 3, 4, 0. Then I guess it's plus c. No, it's not plus c, that's not. So now you have to do negative cosine 4 pi plus, I guess it's going to be plus because you do two negatives, cosine of 0 pi, which is just 0. But you divide by pi. Oh crap. Pi xt, not just t. Okay, okay. Okay. Guess, I never thought about it like that. This? This right? Okay. So then, 4 times 180. 480 cosine. So now it's negative 1 over pi plus cosine of 0 is also 1 plus 1 over pi. So that also means it's 0, right? This is the same as the integral from negative 2 to 2, and sine pi of t is an odd function, so the integral is 0. You're saying that it's equal this? And it's an odd function. And all odd functions are 0, right? Oh, I guess I figured it out here. Let's do it my way. Okay. Well, then it's going to be plus 0k. So 26 over 3i minus 16 over 3j plus 0k. Oh, that's the answer. Okay. Been a while since I've done something right. So let's go. Okay. Now we got one more problem. We got another problem like that, and then we're gonna have to go to the next thing, to the next set. Okay. 36. Plus t squared. the integral of this times I plus tj plus t squared k. My major, I'm studying electrical engineering. Like, yeah, basically it. I haven't really got into the electrical engineering part. Like, I'm still doing my like basically core math and physics courses. So like, I haven't learned too much about electrical engineering yet. Basically saying. Okay. I t squared plus squared over squared a k. Okay. Now we gotta do this. Okay. Which university? I don't know if I'm allowed to disclose that. Allowed? Okay, let's do the chain rule. I guess I'm just gonna tell you. Secret. The secret universe. Okay. The quotient rule. I gotta look up what the quotient rule is. Okay. Don't need the quotient rule. Oh yeah, that's for derivatives. Okay. Let me think about what I need then. Okay. Am I supposed to do U substitution? This is a trig function. Oh my god. I don't know how to do this. That was okay. Let's look. Secant x. Okay, one. Like this. Okay. Yeah, basically I have no idea. I don't know. Are you guys gonna have to walk me through it? Here, let me just look up the integral calculator. Otherwise we're gonna be for a while. Divided by n plus x power of 2. This thing's in the way. Need dt 1 plus tan squared x becomes secant squared x. Okay. Like this. And you need dt was secant squared x dx. Okay. Get 1 over 1 over secant squared x, which becomes cosine squared x. Oh yeah, because gas dt. And then it's like that. Secant squared x. T plus secant squared x dx. So now this, you're saying that this is cos squared x times secant squared x dx. Yep. What? And then you integrate it, which is 1 dx. 1 dx. Cause is that a trig identity? I was always bad at trigonometry. Oh. Oh yeah. Okay. What? And so what? Like now I take the derivative of 1? I don't know where you guys are going with this, because in the integral, I put in the integral calculator and it just says that just has its arctan. Or no, wait, I did it wrong. I didn't do it wrong. But they're just saying it's a standard integral, so you're just supposed to know it, right? Okay. On. The problem go. Question 36? Okay. So what? It's arctan I, but here x equals arctan t. Yeah, I have no idea. Should have reviewed. I was in calculus 2. I did really bad in calculus. That. Now, I can put that, the first one. We're gonna go t over 1 plus t squared. And you're supposed to substitute let e plus t squared. Yes or no? This question I have no idea. If this appeared on the test, I'll get 0 marks. T integral t, supposed to substitute over t equals dt. Okay. 2 equals this over 2t. This and this are supposed to cancel out, right? That's going to be 1 over 2 derivative of 1 over u. And the integrals don't change because there were no limits, right? So it's gonna be negative 1 over u, or it's like this, right? Is this allowed? Yeah. Integral, it's gonna be u 0, 0. Don't know. This is a standard integral. Okay. So it's not that. 1 over x, the derivative equals ln x. So 1 over u, the integral equals ln u. Okay, silly me. Okay. So now it's 1 over 2. It's ln u over 2, and then you're supposed to replace it back with t, right? So it's ln 1 plus t squared over 2. U doesn't appear. Okay. Plus this 1 plus t squared over 2. 3. Okay. Gotta go. Thanks for helping me. Nice night. Day. Okay. The last one is t squared. Okay. Plug it into the integral cap. Power of 2. Okay. Stuff is met. Okay. So what if it's over here? I put plus 1. Okay. Here's x squared over x squared plus 1. Basically, I'm just looking at a thing that gives me the answer. I got no idea what's going on. X squared. And it takes away the spirit, but yeah. I can't sit here all day. 1 minus 1 over x squared plus 1. Apply linearity. Looks like you can split it up like this. Derivative of 1 dx is derivative 1 over x squared plus 1. Did it right here, right? So we know that the integral of 1 over x squared plus 1, or actually we did it here, and it's not supposed to be x, it's supposed to be t, but you know how it is. I put in x because I didn't want to put in t because to find the thing or whatever. Yeah, if I was more organized, I would know that this is negative arctan t. This is also t. Is it t minus arctan t? So now if you go here, okay, here was j, and k is t minus arctan t. K. Okay? So here, okay, fine. I'll rewrite it like very nicely. One plus t squared over 2 j plus t minus arctan t k. Okay. Like this. There. That's the answer. Yeah, let's go. Okay. Textbook stop load. Darn it. Okay. Vector calculus. Okay. Okay. I got a couple more questions to do, and then I don't. Time is it? 30. Guess tomorrow. Okay. Thanks for coming, helping. Guess you taught me stuff, so thanks. Find the length of the curve traced by the given vector function indicated interval. Seven. Questions 1. Find the length of the curve traced by the given vector function on the indicated interval. Okay. That means sine t I a t j c t k this and that 0 t I. Okay, you know what? How about I just okay. Find the length the curve traced by the given vector functions the indicated interval. Okay, but you know what? Before that, I have a break. I've been streaming for 2 hours. So I'm gonna take a. Just gonna leave this here, and then I'm gonna take a break for like 15 minutes. But okay. Oh, whatever. Okay, one person in chat. To the front. Up. Edit. Edit. Text. Back at 8 plus I don't know. 15. What's the answer? What's the math answer? 40 D 53. Back at 10:50. Well, in 15 minutes. Alright, hello. Okay. You know what, to be honest, why did I even... Okay, back to the camera. Okay, to be honest, why did I even do that? Because, I don't know, I feel like I should end the stream right now, but, okay, let's keep going. Because, like, there was really no reason to take a 15... Okay, whatever. Find the curve traced by the given vector function on the indicated interval. What does this mean? Find the curve traced by the given... Like usual, I think I just have to... Okay. Dx over dt, dy over dt, and d. Okay. Basically, what they're saying is that it's like this: 2 pi 0. And what they're asking is, they're asking for the derivative of a cos t, a sine t, and ct k, which is, I don't know what the a and t stand for, but I can derive cosine. It's supposed to be a, b, and c. Negative a sine t I. Since this is an even question, you're supposed to square it too. Plus a cos t j. Supposed to square this as well, and then plus ct. I guess if you're deriving c, it's just gonna be c k, whatever c is, squared. And now you're supposed to root it like this, and then it looks like you can sign it. Sorry, I had to sneeze. Okay, so yeah. Now it's like this, and then you're supposed to take supposed to square it, so I think it's like negative a squared and squared t I a squared cos squared t j squared k. And then you're supposed to root it, so I don't know. It goes away after. Now it's negative a sine t plus a cos t plus c. Okay? And now you're supposed to... Wait, I already took the integral. Oh no, it's all wrong. You're supposed to do this, square it, root it, and then you're supposed to take the integral. Okay, hold on. Also, I just got really tired. Okay. 41, 43, and 7. Okay. Here they're trying to solve the arc. Okay. Okay. Figured it out. Never mind. No, I didn't. There's a 5 over 1. Should be 7. Okay. Okay. Here's what's gonna negative a now you take the square them and then root. It's okay. Sine 90. Like 90 sine 1. Negative AI plus cosine 90 cos is 0. 0j plus ck. ck. I don't know what is C and A stands for though. So 0 sine is 0. 0i plus A j plus ck. Again. Okay. I can't help but feel that's not correct. And probably. Okay. 43. RT T cosine 2ti plus ET sine 2tj ETK 0 t I. Okay. Basically, let's take the derivative. Okay, how do you take the derivative? T times cos 2t. The differentiation by parts, or integration by parts. No, it's the derivative. So yeah, it's the chain rule. It's basically t times sine, like times 2 sine 2 plus t cosine 2, because derivative of t is just, now the derivative of e sine 2t, that's et times 2 cos 2t plus et sine 2t. And then this is I, this is j, and k is et, so it's et again. Okay. Now all you have to do is do that. Square it. You square it and then you root it. Which means that basically nothing happens, isn't that right? Hold on. Okay. Because it's a different result, so okay, so let's square everything. Which is et times cos 2t, right? Square 2t plus 2e. Crap. And also that's, I'm not even squaring the right thing. Isn't this stuff too hard? Isn't this stuff too hard to learn? Okay, fine. No, I'm just being late. Just take it easy. Now, if you want to square it, it's going to be t sine plus e cos 2t. So, start. Okay. Get t times this. Square times if 4 squared 2 plus get t squared cos squared 2t. Okay. And you're supposed to take the root of this, which just means all the t, all of it cancels out, isn't that right? No, 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 no. You're supposed to leave it like that. Probably. Now j is et times negative 2 sine 2t plus e. Just wrote the top thing again. T times 2 cos t plus et sine 2t. Okay, basically it's et squared times 4 cosine squared 2t plus et squared sine squared 2t. Okay, Yeah, I'm a mess. See. K is equal to ET squared. Okay, so now all you have to do is go look at where they cancel out, and then go find it. E here. E2. Oh my god. Doesn't look like anything cancels out. So you're supposed to add them all together, and then you're supposed to cancel it. Yep. Guess I'm stupid. Okay. This we're gonna have to go 8, and I'm gonna have to write everything over again. ET times -4 sine -4 sine t plus ET cos 2t. ET cos 2. ET times 4. Oh, why did I took out the t's, but I didn't square them. Oh my god. Okay. Just rest for a little bit. Oh. It's basically this, right? No, it is this. And then you square it, and then you do it, and then you add them. Okay. Then you're supposed to integrate them after. Which isn't it like the exact opposite? Okay. Okay. Well, my brain actually just got fried. Okay, so now we're gonna skip ahead like 5 chapters, and we're gonna go to the directional derivative. 4 chapters. However, it doesn't look like my textbook is loading. And like maybe I should just leave it as like I should just leave it as me doing 1 chapter, then like the other thing is like 2 chapters. Like I'm not gonna freaking study. I need to study 13 days, so I study the 13 chapters. How many? That's around 2 weeks. If I did one per, even if I did one per day, if I did one per day, I would like barely make it. Plus, I have other courses to study for. Ah. You know what? I am happy. Video game. To watch TikTok. Raw. To just chill and have fun. Life is all about relaxing and having fun. Gradient of function. Vector-based differential operator. Okay. Yeah, I learned this in class. Basically, there's this like triangle thingy. And it means I and X. This is called I think this is called like die or something. Die. This little symbol. It's not the letter A. it up. Guy Greek symbol. Called gamma. Die. Okay. I'll find it. Make this symbol up. Okay. This one symbol is called, the triangle symbol is called Del or Nabla, but they don't tell you what the swirly thing is. I missed it. It's in the, oh. It's in the last chapter. Okay, they don't tell me. Who cares? Okay. Are gradients of the respective function. So here they're saying, here's a question, compute f(i) for f of xy equals 5y x cubed y squared. Okay, basically what they want us. You're supposed to use the partial derivative. So this is die over die x or 5y x cubed squared plus die over die y 5y minus cubed. Okay, so basically what they mean by this directional derivative is you only derive for x, or you only focus on x and you leave the y as constant. So 5y, you leave as 5y and then minus 3x squared because that's the derivative of negative x cubed. And then you leave y alone, y squared. Only for x. So this is I, and now here's y. So now you're supposed to focus on the y and ignore the x. Now plus 5 minus x cubed times, and what's the derivative of y squared? It's 2y. 2y. So let's see if I got it right. Did I get it right? Hold on. Just a moment. Here's the, what happened to the frickin' 5y? I didn't get it right because extremely stupid. Oh, I'm not. And put yourself down. It takes rain to grow a tree, not thunder. That's what they were saying back in the day. Sisyphus. Something. So otherwise, Because the j part is right, or the y part is right, but not the I part, the x part. How's that possible? Oh, I know. I don't know. Gosh darn it. Gradient at a point f x y z. Okay. -2. Okay. Well, alright, yeah. Y first. Sorry. Okay. Let's do the derivative here. Because like this is supposed to be. This is why I put z cubed. Okay. Xy squared. 1 times plus 6x cubed. Okay, is that right? No, it's not right. I squared 6x. Why does z cubed? I don't understand why z cubed gets cut out because it wasn't even supposed to thing. Okay. Okay, you know what? How about I just leave it here and then I do a stream. And I'll try to study a little more so that I know what I'm talking about. What do they say? They say when people are lying on Twitch, Kappa. Kappa. That guy got cancelled. Log channel. Okay, whatever. Watching, like and subscribe. And follow. Nice day. Bye bye. Maybe I'll. Okay. Bye bye. Bye bye.